All right, guys, today we're going to talk about study types, bias, and margin of error. So up until this point, we've been working with sets of data, and we've been finding the mean and the median and standard deviation and regression and all that different information. But now we're going to look at actually how data is collected. Okay, so we have a few definitions we have to talk about. The first one says that a population is a group of people or objects that you want information about. Okay, a population can be very large or it can be small. A population could be every person in the United States, or it could be every student at Science Hill. Okay, so those are both different populations. A sample is a subset of the population. So if I was looking at the United States as a whole, I could maybe look at just the people in the city of Johnson City. That could be a sample. Or if I was looking at Science Hill, just the students that are in band, that would be a sample. Okay, so over here at number 1, a school newspaper randomly selects 30 students from each grade level to participate in a survey to determine the opinions of students at the school. What are the sample and the population in this scenario? So the sample is going to be the smaller subgroup. So because we are randomly selecting 30 students from each grade level, that would be our sample, 30 students from each grade level. Now, the population is like the big group. What are the people, the big group that we're trying to study here? And so the population would be the students at the school. Okay, the number of students, it could be 100 students, it could be 2,000 students, but looking at just this subpopulation, 30 students from each grade level, and then using that to make inferences about the entire population. So this is going to be the students at the school. Okay, and again, a population can be very big or it can be very small, but a sample is going to be a subgroup of that. Okay, now why do we need to know the difference between a population and a sample? Sometimes it's easy to get information about an entire population. For example, I could go to the records and I could look at every single student's GPA at Science Hill. I could pull that data and I could run a statistic, I could find the average. Okay, and I could do that of the entire population. Okay, but if I wanted to know, for example, what students wanted to do, like how many students were going to go to college after graduation, I may not be able to pull every single piece of information on every student because that's not in our records. So what I could do is I could do a sample survey. I could survey maybe 200 students at our school, and that would allow me to get an idea of how many students want to go to college after high school. Okay, so when we talk about those different types of numbers, we have different words for them. So a parameter is going to be a measure that describes the population. So when I took every student's GPA and ran the average, that would be a parameter because I could figure out from every single student's information what the average GPA at Science Hill was. A statistic is a measure that describes a sample of the population. If I randomly went to the cafeteria and I interviewed 200 random students and asked them about their plans after high school, I could then use that information to make a prediction about the bigger population. So that's why we hear statistics a lot, is because it's very hard to set up a parameter because you have to have all the data, and that's sometimes very hard to get. So over here at number 2, it says a high school has 3 lunch periods. In a randomly selected lunch period, 24% of students brought lunch from home. So this is the information. 24% of students brought lunch from home. The question is this a parameter or a statistic? So did they interview every single student or did they just take a subpopulation? So because they only randomly selected a lunch period, they didn't go to all the lunch periods, this is a statistic. Okay, they're going to take the information from one lunch period and they're going to use that to make a prediction about all the lunch periods. Okay, now look at number 3. At the end of its first year of business, a movie theater collected data on how well its concession stand operated that year. The theater used its total yearly concession sales and numbers of tickets sold to calculate that the mean amount spent at concessions by a moviegoer was $8.14. Is this a parameter or a statistic? So we can see that they found the mean for moviegoers was to spend $8.14. Well, because they took the total yearly concession sales, so they looked at every single sale that they sold. So the sales from the concessions and the number of tickets sold, they could look at every piece of their data because they track that. This is a parameter. Okay, again, it comes down to, is it every single piece of data or is it just a sample piece of data? Okay, so this again is what we talk about: samples and population. Parameters and population go together, they're both P's, and then sample and statistic go together, they're both S's.